Okay, everyone, this video we're going to be looking at how to use the algebraic method to determine the overall displacement for two different vectors. So what I have here, I have a trip that had two components to it. I went 85 meters south, 43 west, and then I went 65 meters south, 30 east. I want to know the overall displacement for this entire trip. So what do? Well, we draw a little sketch at first. So remember, it's not a scale diagram. We draw a sketch. We have to draw it properly. So here I'm measuring for the first vector the angle from the south over to the west. So I want to make sure I draw my south first. Then I go to the west. That's my x component. And my y component's over here. It's going to the south. So again, in this sequence, so again, I'm measuring from the south over to the west. Now on this side, I'm going to be doing the similar breakup over here. The x and y components, except here, are going to be going south and then over to the east. So south and then east. So be careful when you're sketching these. You don't want to draw the opposite way, otherwise it's going to be incorrect. Now once we have this, we're going to use our trig to determine our x and y components. So on this side, for the first vector, the y is going to be the adjacent, so we're going to be using cosine. X is going to be the opposite, so we're going to be using sine. Similarly here, we're going to have the y being cosine and the x being sine as well. And you don't do any rounding here. Just keep all your values. Just remember to include the directions. Here I'm going south, here west, here south, and here east. So now we've got the x and y components. Next thing to do, find the total. So in the total of the y, I'm going to be adding these two together. So 62.2 and 56.3 south gives us 118.5 south. Now the x, you have to be careful. I'm going 58 west and then 32.5 meters east. So when you're adding these together, remember you have to subtract this value from the 58. So you end up with 25.5 meters to the west. So just be mindful of that. Now that we've got the x and y components, we can draw a sketch to determine the resultant displacement. So there's two ways we can sketch this. We can put the south first and then the west, or the west first and then the south. It really makes no difference. It's going to be the same result, and the only difference is where I'm measuring my angle from. Here I'm measuring from the south, here I'm measuring from the west. So I look at this situation first. So the way I drew my triangle here, we're going to be using Pythagorean theorem with my x and y values. I end up with 121.2 kilometers for dr, that's the size. Now my angle is going to be opposite over adjacent. Now remember, you're always measuring from the beginning of the trip here, so be careful there. I end up with 12.1 degrees. So my final answer with significant digits is going to be 120 meters. And I'm going to be looking at south 12 degrees over to the west as my actual direction. Now what if I drew my opposite triangle? What if I did this triangle? Well, it's the same thing. The only difference again is the angle. So the resultant displacement will be identical. Now the angle, remember, it's over here on this side now. I'm measuring from the west to the south. So when I do this, it's opposite over adjacent. Here my angle is going to be 77.9 degrees. So my final answer is going to be 120 meters west, 78 degrees south. And again, both of these are equivalent to each other. Now the last part of the question has one quick thing to ask. It asks you, what is the distance here? Now for the distance, remember, it's just a regular d symbol. We have 85 meters, no direction, plus 65 meters. And when we add these together, we end up with 150 meters total. So that's a total distance. There's no direction. You just add the two numbers in together. That's it. So hopefully you did well. Just be careful with the formatting. Make sure you round appropriately with significant digits. And that's it. Take care.